in this video I plan to update my app code. So we've made a lot of changes over the last couple of videos, and my Solara app no longer runs, so we will fix that this time. In a previous video, I think I mentioned that I'd accidentally dragged a dependency folder that has like all the stuff that this app depends on through like a mouse clicking error. I drug it into a different directory, and that's what broke the app before. I figured that out eventually, moved it back, and everything's fixed from that perspective. So now anything that's broken is because of our code changes. Okay, so I went ahead and tried to run it, and it's complaining about not having this create graph method, which I know we deleted. Okay, so yeah, we've totally changed the way we interact with the graph. We now have this TSP graph object. Okay, so let me just copy this because I want to load the benchmark data set, not the random one. And then our model parameters also need to be updated. Okay. This position, I think we need to change. So we have a .pos on our graph object, but we are passing in the model there. Okay, this is a little annoying because we're not saving that object. So therefore we can't access that method. I think we should change that fact. We should just persist that thing. Because now I can do this. We have this persisted as an attribute, and now we can access that property. Okay. I don't know that we kept this property. Let's see. TSP distance. So okay, let's see if this works. Okay, where's this? Line 37 in make graph. All right, I know we did change what those are called. Add edge properties. So we have visibility. Although it might be more interesting to see the pheromone there. Now what's it complaining about? I'm going to go ahead and print this to see what it is. Unstack. Oh, ant distances, TSP distance. Line 56. Okay. I don't really understand. So we have step, agent ID. We also have those as columns. Yeah, I don't quite understand what the structure of this thing is yet. Okay, so step and agent ID are the indices. It seems to not like. Index must be a multi-index to unstack. It seems like that's what we have, right? Because this is a list. Either way, we can eliminate that call and see what it does. Okay, we don't seem to... Oh, wait, I do see edges, or something's going on in there. All right, let's run this, see what happens. Okay, step and agent ID. Well, first of all, I don't think we want every ant here. I mean, that might be a cool plot, but index must be a multi-index to unstack. How is this not the multi-index? Oh, I see. Well, I see one thing. So this is the value of every ant, right? Because we have, I suppose, 79 ants. I forget how big this. We should have 100. I guess they're not ordered correctly. And then everything is 0. And then we get, for the next step, which is the first time we actually do it, we have the values of every TSP distance. So for every ant in that first iteration. So really we want a different line. So we would have like 100 different lines, which I don't know that that's going to look that great. So what I would rather do is get away from the ant level information for now. And instead get the model level. So we have, let's see. Colony stats. Okay, what did our first step do? We got zeros, okay. So I want to plot this best distance iter. So that's like out of all the ants that ran in that iteration, which one was the best? So I will do colony stats. All right, let's step this a few times. All right, let's just run it. Okay, another thing I think might be cool is if we fixed this plot so that the edge width was proportional to the pheromone density. Because then that would show us like which solutions and branchings are kind of being selected by the ant colony. Okay, so this seems to be working, right? It's like every iteration we figure out what the best is, so the minimum of this is the best solution found yet. We could make a separate plot for that. And actually, let's just go ahead and do that. Best distance yet. Okay, we don't need that. Don't need that. We should get rid of this. So this should only be decreasing because it's the minimum. So the fact that it's flat means that we haven't yet improved upon the minimum. Okay, now we've dropped again. All right, nice. So doing that work of refactoring so that each step is a full solution is really paying off, because now we can leverage this data collection stuff and get sensible things very quickly. That's great. Okay, so now let's go build the graph. Best distance iter. I think we should eventually do something with the ant distances. But I don't know what that is yet. So I'm going to basically create this new function to hold it, but I'm not going to call it. Okay. Okay, so now we need to fix our drawing here. And again, I want to use some function of the pheromone to be the edge weight. I think we also need to change the node size because it's too big. I don't know what the default is. Okay, that looks better. So initially, all of the pheromone is like 1e -6, so it's very light. Let's see if we get any changes as this goes. I don't know, I'm not seeing any like thicker lines emerging. Which is kind of surprising. Model.grid.g. Interesting. So is this just collected one time? Maybe to make this a little more clear, instead of printing all of them, I'll just print a single. Let's see. Now hold on a second. Why is this not updating the pheromones? Oh, okay. It's because I'm manually calling this to update the pheromone. And that's not being called in the app. I should probably make that part of the model, right? Okay. So that means the results we've gotten so far are just because of random search, basically. Okay, so we initialize, we run a step. We increase the number of steps. And then we should call update pheromone. Which means I should delete that here. Okay, let's try this. All right, now I'm starting to see some edges. Nice. Oh, and you see them getting like darker, right? Okay, this is very cool. Like this one, there's a bunch of different paths it's exploring, right? It's not like clear. But if you're, I don't know, at this city, you're either going here or here. Or clearly like this is the preferred. So you see different branchings at different nodes. All right, this num steps is just useless. I need to get rid of that. Maybe we should multiply this by some constant that... Wow, it hasn't improved in a long time. Seem to like quickly find something good and then it's sort of getting worse. All right, let's eliminate this num steps. Oh, since that's a property, I probably could have just done and not had these various functions. Oh, it's coming back down. So before I save this, I'm gonna all right. Okay, yeah, that's like just as good. So might as well reduce the code, right? Okay. All right, let's see what this does. Okay, this is a little bit more accurate, right? It's like everything is equally probable, and then it should sort of prune it down. Okay, I think we have it basically running, right? The only thing we might want to do is add some controls here for the various hyperparameters. So let's take a quick inventory of that. Okay, just doing a little bit of cleanup. I want to see if this makes that other plot look a little bit better. Ah, it does. Okay. That makes it look slightly better. All right, back to finding the right hyperparameters to expose. Okay, so we have in update pheromone, we have Q, we have rho, which is about the evaporation, right? And then in the ants themselves, okay, Q just gets passed to that. All right, the alpha and beta. So how do we expose that well? So decide next city is called here. I think we want alpha and beta to be ant level parameters, because where I'm going with this longer term is to have another algorithm that decides the parameters of each ant so that I can have heterogeneous populations. So one ant might have one alpha and beta, but a different ant could have a different alpha and beta. So I would like to do this. Okay. All right, let's make sure we didn't break anything. I don't think we have. Okay, cool. And now at our model, when we create the ants, let's see. Okay, right now I'm going to just have a single alpha and a single beta, and every ant will have the same one. But in future iterations, I'll probably create a different class here that allows me to do that differently. Maybe pull from a distribution, something like that. So that means I need to expose new parameters. And alpha and beta. Okay. I like to name the arguments. So unique ID model. Unique ID equals I. Model equals self. Okay. This should all be the same. Great. Now we can expose our sliders. And for that, since again, things have been changing, I'm going to here, slider int. I want to float. Changing the agents. Okay, I don't like that you have to reference the class name with a string because now I don't know what options I have. But let's start with this. This is under model parameters, okay. So let's see, the alpha is 1. So we'll put it from like, I don't know, 0 to 5, I guess. Min is 0, max is 10, step is 1. All right, let's see if we get a slider. Yes. Okay, let's bump it up to 5, see what happens. All right, and let me see, does alpha change the weight on the pheromone or the heuristic? Okay, alpha changes the weight on the pheromone. So exponent on pheromone strength. Whoops. Print beta. Heuristic exponent. All right. I'm going to check out the documentation, see if I can figure out what other options we have. Slider. Not great. All right, I'm trying to figure out how do we get a float value. I guess one thing I can do is just search in GitHub. Slider float. Oh, okay. Apparently it's a Solara thing. From Solara Viz. Okay. So I think if I just call it slider, then I can just do it like this. Let's try it. Value min max step. Is that right? Value min max step. Okay. One. Slider is not a supported input type. Okay. Here, I'm going to comment this one out until I can fix one. Okay, so apparently it's called slider float. So let's put a lower weight on the pheromone density. See what we get. And this is looking pretty good.